Hey everyone, welcome back to part 4 of this video series. In this video, I will walk you through the assembly of the Class D amplifier using the components I covered in part 3. If you haven't seen that video yet, I highly recommend watching it first to get the full context. So let's jump right in. Here's a basic block diagram showing all the components we discussed in part 3 along with their input and output terminals. I use this to explain how each board connects to the others. To keep things clear, I'll break the connections into 3 parts: the AC circuit, the DC circuit, and finally the signal circuit. I recommend, before mounting anything into the enclosure, I suggest building and testing everything on your workbench first. This makes troubleshooting much easier if you find yourself having issues during the build. So moving on, starting with the AC side or the alternating current side, as you can see, the mains power comes in with the live wire going to one of the terminals of the main switch. The wire then exits from the corresponding outgoing terminal of the main switch and feeds both the power supply and the center tapped transformer. The neutral wire here connects directly to both the power supply and the center tap transformer directly. The center tap transformer in my build supplies power to the tone control board. If you don't have a tone control board in your design, or if your amplifier board has integrated controls, then you won't need this transformer. Now, also an important note, if you're using a switch like mine with a built-in 12-volt DC LED, make sure you check the terminal layout of that switch. Do not connect the AC to the LED terminals. It will destroy the LED and probably you'll destroy yourself as well. Next up, the DC side. The power supply outputs 36 volts DC, which feeds both the amplifier and the 2 DC to DC step-down converters or buck choppers. At this point, turn on the AC supply to the system to power it up and measure the output voltages from each converter using your multimeter. I set 1 to 12 volts for the status LED on my main switch and for the time delay module. The other buck converter is set to 5 volts for cooling the fan. So with regards to setting the buck converters, this can be done by adjusting the potentiometer on each device. Once everything's set, switch off the AC supply and wire up the time delay module, the status LED and the fan. Now, just a word of caution. If you decided to use 48 volts DC instead of 36 volts for your project, ensure that your amplifier board is capable of 48 volts, as well as the step-down converters that you may be using. From my experience, for a 48 volt application, it will be more economical to get a separate AC to DC power supply rated accordingly for your ancillary components, as 48 volt step-down converters are either too expensive or difficult to source. The AC circuit will have to be modified slightly as well. So here's a quick look at the combined AC and DC circuits. Turn on the supply and test that everything functions as expected. You can also adjust the time delay relay here at this stage, and that can be done by adjusting the screw on the potentiometer, and I set my relay to click on or off at around 5 seconds. Now moving on to the signal wiring, my board has a soft start or muting feature, and this requires pins 1 and 3 to be in the open state for the speaker outputs to unmute. So what I did was I wired these pins to the normally closed and common terminals of the time delay relay module. After a few seconds, the relay opens the circuit, thus unmuting the outputs. And that avoids those unwanted nasty DC speaker thumps when you switch the entire system on. Now you can connect your audio signal path. You can start by connecting your RCA sockets to the inputs on the tone control board. Then from the output of the tone control board, you can then connect to the amplifier's input. If you're not using a tone control board, you can connect your RCA sockets directly to the amp input. Please make sure that you use shielded cables for these two connections and ensure that both ends of the cable shields are grounded. Also make sure that both RCA sockets share a common ground. Finally, wire the amp outputs to the speaker binding post, carefully maintaining correct polarity. So once everything is connected, your setup should look like this. And now you can hook up some speakers, slap on an audio signal, and test for proper functionality. Here's a picture of what my mock-up or amplifier assembly looked like before I mounted it into my enclosure. So once you're happy with the results, you can then mount everything in the enclosure. If you followed my advice from part 3 and mocked a layout when determining your enclosure size, then this part should be really quick. So basically all you have to do is just mark your mounting points, drill the holes, and then use the PCB standoffs for installation. Okay, so taking a quick look at my amplifier. In my case, I mounted the power supply towards the rear of the enclosure. Although the power supply is close to my audio signal inputs here, I have no interference. My amplifier board, which is here, is mounted more or less centrally, such that I am able to get airflow through the heatsink via the side enclosure vents. Right, so basically this is the lid that goes on top, and I have these vents on either side. So you would see that the heatsink on the amplifier, the fins are mounted such that they are perpendicular to these vents to get optimal airflow through and cool my amplifier sufficiently. Okay, so with regards to the fan, I mounted the fan centrally above all the components on the lid of the enclosure. So as you can see, there's the fan right here, and when this lid is placed on top or situated back into its spot, the amplifier sits directly above all of the components. So I drilled holes on top of the amplifier enclosure to allow the fan to suck in air from the top, push the air down towards the components, and then it will then move off over through the vents on the side. So initially I had mounted the fan to the enclosure lid. I did a butt mount, but what I found was that I was getting a lot of turbulent noise coming from the fan because the air was being sucked through these holes, right? And obviously these holes are not of sufficient surface area. So to reduce the turbulent noise, what I then did was, if you can see this clearly, I'm not sure if you can. Okay, there we go. I mounted or used PCB standoffs to create a gap between the fan and the lid, and that reduced my turbulent noise tremendously. With regards to the installation of the other components, such as the time delay relay and my buck converters, I just played around with them and saw where they fit in terms of space within the enclosure, and I tried to stack them as far as I could. So taking a look at the power switch is mounted centrally onto the front panel. This resulted in the tone controls being offset towards the upper half of the amplifier face, and the tone controls were kind of an afterthought. Initially I didn't want tone controls, and then I decided to add it at a later stage. Hence I would have probably worked on better placement. The speaker terminals and the RCA inputs are mounted onto the rear panel. The placement could have been better, but this was just my preference. Right, there's a better view of the amp at the back. Also, just a word of advice: when mounting your speaker terminals and mounting your RCA inputs, ensure that the gaskets provided with these little gadgets are used and they are providing isolation from the enclosure. The AC cable enters through the back of the amplifier, comes in and goes into the AC circuit, as you can see here. I should have actually installed maybe some stress relief, or maybe a female figure 8 footing here, but I didn't have the time, or those at the time, so maybe I will add those at a later stage. I did use my glue gun, however, to mock up a little gasket at the back to prevent the cable from being damaged against the metal. Okay, so tips for drilling. After making your holes for your PCB standoffs and for your speaker input ports, maybe your RCA sockets and whatever it may be, use a larger drill bit to deburr the drilled holes by hand, and ensure that all the metal filings are removed, because you don't want these things shorting out any components later on. So for the standard holes that are drilled, I used standard steel bits, and where the holes were above 10 millimeters, I actually used a step drill bit, which was quite a nice tool, which I got from a local hardware for 60 bucks. The step drill bit can make holes from 2 millimeters right up onto 32 millimeters in 2 millimeter steps. So I think this drill bit was a great investment. Yes, and also to mention that these knobs here at the front did not come as part of the standard kit with the tone control board here. I actually bought these knobs separately. They are aluminium knobs, and I just wanted to make the amplifier look a bit better. But overall, this is how my amplifier turned out. So just to give you a quick rundown of the components once again, we've got your power supply here. This is rated at 36 volts and at 8 amps. This power supply here provides DC power to the amplifier board here, right? And it also provides a supply to this little buck converter here, which is set via this little potentiometer here to 5 volts, which then powers the fan. The power supply also provides power to another buck converter sitting down here, which is set to 12 volts, again via the potentiometer, and that's then powering the status LED on the front panel of this power switch, and it's also then powering this time delay relay module. Right, this time delay relay module was set to approximately 5 seconds via this potentiometer here, and then this goes into the mute or soft start function of the amplifier and will only turn on the amplifier speaker outputs when the voltages have stabilized prior to switch on. This here is my tone control board, quite a nice board which I purchased from Temu. And down here you can see this is my center tapped transformer, which is rated at 15 volts and 5.5 VA, and that actually seems to have enough juice to power up this board sufficiently. So yes guys, again, overall this is how my amplifier turned out. This was the standard color of the casing. I didn't bother to change the color, but maybe at some stage I'll paint this a nice satin black. As you can see, there's the grill that I used that came with the fan. Yeah, again, this is what the front panel looks like. The amplifier feels nice. It's got a nice metal feel. This is what the rear of the panel looks like. I've got my RCA inputs, and I've got my speaker outputs, and the power cable comes in there. So yeah, overall I think that this amp came out quite nice. So yeah, let me know what you think in the comments. Okay guys, so this is the end of part 4 in terms of the amplifier build. I hope you enjoyed the video. I hope it gave you a better insight, made you a bit more confident in wanting to maybe build your own amplifier. And so yeah, in the next and final video of the series, I'll do a power output test of the amplifier that we have just built, and we'll do some sound testing. I'll also share what I would have done differently from this build, and maybe I'll answer some questions that you may leave for me in the comments. Please don't forget to like, subscribe, and turn on your notifications to find out when the next video will be uploaded. You don't want to miss it. Thank you so much for watching, and I'll see you on the next one. Thank you.